Hello everyone. In this session, we are going to study the types of hardness of water, what are the different units of hardness of water, and how we can find a hardness of water if it contains different dissolved impurities. So let's begin with what are the types of hardness of water. So first type is temporary or carbonate or alkaline hardness. So the hardness in water due to presence of carbonates and bicarbonates of heavy metal salts which can be easily removed by boiling is called as temporary hardness. So we know water is hard due to presence of salts of heavy metal ions. But if those salts are carbonate or bicarbonates, then the hardness due to those salts would be temporary carbonate or alkaline hardness. Why it is temporary hardness? Because it can be easily removed by boiling. So let's have a look at what exactly happens here. So this first salt is magnesium bicarbonate. Second is magnesium carbonate. So if these salts are present in water, these are bicarbonate and carbonate salts of magnesium. So due to this, the water will have temporary hardness. Because when we boil the water, okay, if the water contains these two salts and if we boil it, those bicarbonate and carbonate of magnesium gets converted into insoluble magnesium hydroxide plus CO2 gas is released. That means the soluble salts get converted into insoluble salts on boiling. That means the hardness is removed. Similarly, if calcium bicarbonate is there, again this is bicarbonate salt of heavy metal calcium. If it is present in water, then water would be hard, but on boiling, this soluble calcium bicarbonate gets converted into insoluble calcium carbonate plus water plus CO2. So the soluble salts are getting converted into insoluble salts. That means they are removing the hardness of water. The hardness of water is getting removed because water soluble salts responsible for hardness of water are getting converted into water insoluble salts. Second type of hardness of water is permanent hardness, also called as non-carbonate and non-alkaline hardness. So, as the name suggests, if the water has salts of heavy metal ions, but those are other than carbonate or bicarbonate salts, then the hardness due to it would be a permanent hardness. So, which are the examples of those salts? Like calcium, magnesium chloride, calcium sulfate, magnesium sulfate, calcium nitrate, magnesium nitrate, ferrous chloride, and cupric chloride. So, salts of heavy metals like magnesium or calcium, other than carbonates and bicarbonates, if they are present in water, then the hardness of that water would be permanent hardness. So, there are two types, one is temporary and another is permanent. So how we can calculate the total hardness? So hardness of water due to all the hardness causing salts is total hardness. So total hardness would be the sum of temporary hardness plus permanent hardness. Let's have a look at the difference between temporary and permanent hardness. So temporary hardness, it is presence of bicarbonate and carbonate salts of heavy metal ions. So the heavy metal ions like calcium, magnesium, iron, aluminium, manganese, etc. So the group 2 of periodic table, it is of heavy metal ions. Permanent hardness, it is caused due to presence of soluble salts of heavy metal ions other than carbonate and bicarbonate. So it can be a chloride salt, sulfate salt, nitrate salts, and etc. Temporary hardness, it is, as the name suggests, it can be easily removed by boiling followed by filtration. Because we have seen when we boil the water, if it has salts responsible for temporary hardness, those dissolved salts get converted into insoluble salts. So if it is insoluble, water insoluble, it can be simply removed by filtration. So this is temporary hardness which can be easily removed by boiling followed by filtration. Permanent hardness, it cannot be easily removed from water by simple boiling. For that, we will need special techniques, which we'll see further. So this is the reaction which happens when we boil water which contains salts responsible for temporary hardness. So on boiling, soluble bicarbonate salts are converted into insoluble carbonates or hydroxide form. Like we have seen, if calcium bicarbonate is there, it gets converted into insoluble calcium carbonate, while if magnesium bicarbonate or magnesium carbonate is there, it gets converted into insoluble magnesium hydroxide. Permanent hardness, these salts remain in dissolved state even after vigorous boiling. So temporary hardness, it is also called as alkaline or carbonate hardness, and permanent hardness is also called as non-alkaline or non-carbonate hardness. Now, what are the units of hardness? So, hardness of water is always expressed in terms of calcium carbonate equivalent. Why? Because we have seen calcium carbonate is insoluble in water. We've seen that when we boil water containing calcium bicarbonate, it gets converted into insoluble calcium carbonate. So calcium carbonate is one salt which is insoluble in water as compared to the other salts, plus its molecular weight is 100. So it is easy for calculation purpose. Okay, so how do we calculate the molecular weight of calcium carbonate? So it is the sum of its atomic weight. Like you can see, this is calcium carbonate. So its molecular weight would be sum of weight of calcium plus sum of weight of carbon plus 3 into weight of oxygen. So if you do that calculation, you will get its molecular weight as 100. So formula for calculating the hardness of water in terms of CaCO3 equivalent. So this is the unit of hardness of water, mg of CaCO3 equivalent. So if different salts are present in water in different amount, we have to convert that amount in terms of mg of CaCO3 equivalent of any salt. So how do we convert it? So it would be weight of that chemical which is dissolved in water. It would be magnesium sulfate. Suppose it is dissolved in water. So weight of magnesium sulfate into 50 upon equivalent weight of the chemical. So this is molecular weight of calcium carbonate. Equivalent weight of calcium carbonate is 50. Okay, so that is why we have taken here it as 50. So there are two formulas. One is in terms of equivalent weight, another is in terms of molecular weight. So this is also another formula which you can use. If we are using molecular weight of the salt, then we are multiplying it by 100, while if we are using equivalent weight of the salt, we are multiplying it by 50. We'll understand this further with the help of an example. There are other units of water like milligram per liter of CaCO3 equivalent, mg per liter. It is defined as number of milligrams of calcium carbonate equivalent present in 1 liter of water. Another is ppm, that is parts per million CaCO3 equivalent. It is defined as number of parts of calcium carbonate equivalent present in 1 million parts of water. Okay, so 1 million is 10 raised to 6, and this two units, that is 1 mg of CaCO3 equivalent per liter is equal to 1 ppm of calcium carbonate equivalent. So if 50 mg of calcium carbonate equivalent per liter would be equal to 50 ppm of calcium carbonate equivalent. Other units of hardness of water are degree Clark and degree French, but in this we are going to deal with these two units only. So let's solve a numerical for better understanding. So here we have to calculate temporary and permanent hardness of water sample having following analysis. So water sample is having different dissolved impurities. First is magnesium bicarbonate. The amount is given as 73 mg per liter. Calcium bicarbonate 162 mg per liter, calcium sulfate 136 mg per liter, magnesium chloride 95 mg per liter, calcium chloride 111 mg per liter, and NaCl 100 mg per liter. So we have to find temporary and permanent hardness. So first, let's calculate the molecular weight of all the salts given here. We know molecular weight is equal to addition of the atomic weights or atomic mass, you can say here. So first is magnesium bicarbonate. So its molecular weight would be weight of Mg, plus there are two hydrogens. So two weights, 2 into weight of hydrogen. Again, two carbons. So it is 2 into weight of carbon. Oxygen is 3 and outside the bracket it is 2. So total oxygen is 6. 6 into weight of oxygen. So if you add their atomic weights, you will get molecular weight of magnesium bicarbonate as 146. Similarly, you are going to calculate it for calcium bicarbonate. You have to simply add the atomic weights, plus you have to also multiply the number of atoms. There are 2 hydrogens, 2 carbons and 6 oxygen. Next is calcium sulfate. So it would be addition of weight of calcium plus sulfur plus 4 into oxygen. So it is 136. Similarly, we have calculated it for magnesium chloride and calcium chloride as well as NaCl. So we have calculated molecular weight for all the salts. Now we have calculated the molecular weight and now we have to calculate the hardness. So we know this is the formula for calculating the hardness of water, which is mg of CaCO3 equivalent of any salt, means we have to convert the amount of salt into mg of CaCO3 equivalent. So how we are going to calculate that? It is equal to weight of that chemical. So weight is given in the question, that is 73, 162, 136 of every salt. So weight of that chemical upon molecular weight of the chemical, which we have calculated just now, the molecular weights, into 100. Okay, so here you can see these are the atomic weights of all the atoms. So you can just note it down and learn the atomic weights of these atoms, which will be asked frequently. Now we have the molecular weights of every salt. We have the amount of that chemical in water and we have to convert it into CaCO3 equivalent. So first, for magnesium bicarbonate, it is equal to weight of that chemical. So weight of magnesium bicarbonate given is 73 upon molecular weight of magnesium bicarbonate, which we calculated, it is 146 into 100. So we get 50 mg of CaCO3 equivalent. So we are converting the amount of magnesium bicarbonate to equivalence of calcium carbonate, because we need the unit of hardness in equivalence of calcium carbonate. Similarly, we have done it for all the salts. Okay, and now we have to calculate temporary hardness. So temporary hardness is due to carbonates and bicarbonate salts of heavy metal ions. So if you see, these two are the bicarbonate salts of heavy metal ions. So addition of amounts of these two will give you temporary hardness. Another, we have to calculate permanent hardness. So permanent hardness is due to salts of heavy metal ions which are other than carbonates and bicarbonates, means it can be sulfate and chlorides in this case. So addition of amount of these three salts will give you permanent hardness, and the unit is mg of CaCO3 equivalent. So this is how we can calculate permanent and temporary hardness. Also, if they ask you total hardness would be addition of temporary plus permanent hardness, that is 150 plus 300, it would be 450 mg of CaCO3 equivalent. Similarly, I have other examples here. You can simply try and solve this question. That's all for today. Thank you, everyone.